Welcome back, physics fans. I'm going to do a few questions from the worksheet here, worksheet number 3. It's under putting it all together. We've done a lot of forces and stuff like that beforehand, so let's just go take a look at number 26. A 100-kilogram object moving at 20 meters per second comes to a stop over a distance of 40 meters. What is the coefficient of friction? And that'll be kinetic friction because it is sliding between the object and the ground. Now, it is moving to the right. What's making it move to the right? Nothing. There's no force pushing it to the right. It's moving because it has inertia. It's not saying that something's pushing it. So please do not put a force to the right. There's a normal force, because it's sitting on the ground. There's a force of gravity, because it's on the earth. And there's a force of friction. And that is the free body diagram. Its acceleration is this way, but its velocity is this way. I'm going to call this positive, so we'll have a negative acceleration. I don't know why. Let's just do that. Here we go. And so 20 meters per second comes to a stop. That's VF, VI, and D. So we have VF squared equals VI squared plus 2AD. We don't have the time, so that's why I chose that formula. 0 is equal to 20 squared plus 2 times A times 40. This is going to be 400 plus 80A, and that all equals 0. Put this 400 over to the other side. We get 80A is equal to negative 400. It's on the other side now. And divided by 80, we get A is equal to negative 5 meters per second squared. The negative meaning that it's going backwards. We knew this. Yay! So that's the acceleration. What's the coefficient of kinetic friction? Well, the force of friction, you might want to go mu mg, but we're trying to determine this, so we need this. We need the force of friction. But let's just ruin my free body diagram. The net force is that direction, and there's only one force on it. That's the sum. That's the frictional force. So we need to write down Newton's second law. Sum of the forces is equal to force net. Putting friction there. Sum of the forces is equal to F net equals ma. That's Newton's second law. So the only force is force of friction, and that is equal to ma. So we have m, we have a, so we can get the force of friction. Because it is the net force, and we know what the net force is, do we? It's 100 kilograms and accelerating at 5 meters per second squared. Now it will be negative because it's in the opposite direction that I said was positive. So this is going to be 500 newtons is the frictional force. Nice. So we now have this, and you can say negative because it's the opposite direction. It's always opposing motion, so negative. I'm just going to write down 500 newtons here is equal to mu times the mass of 100 times 9.8. So mu is going to equal 500 divided by 980. And let's pull up my calculator. 500 divided by 980. Whoops, 980. And we got 0.5102. And that is the coefficient of friction. Yay, next question. In an elevator, a 50-kilogram lady stands on a scale that reads 600 newtons. Now, when the scale reads that, it's telling you how much it is pushing up. As in the reading that I sent out to you, this is the normal force on the lady. So the normal force is 600. And there's a force of gravity pulling down on the lady. So free body diagram, every elevator question, the free body diagram is just this, normal force of gravity. Okay, that's it. The normal pushing up on you, and if they balance, you're not accelerating. And if this one's winning, you're accelerating down. If that one's winning, you're accelerating up. Okay. So we're told that this is 600 newtons, and this is mg, which is going to be 50 times 9.8. So this is going to be 490 newtons. This one's winning. So we write down the sum of the forces is equal to F net equals ma. So the normal minus the force of gravity is equal to ma. Is this always going to be it? Well, if it's accelerating up, yes. And if it's accelerating down, it's going to be force of gravity minus normal. So this is an important formula. That's for an elevator accelerating up. We didn't know which way it was, but we determined both the forces and we knew which one's winning. So this is 600 minus 490 is equal to the mass of 50 times A. So this is going to be, what, 110 divided by 50A. So A is going to equal to 2.2 meters per second squared. And the direction for that is up. You need that direction. Oh, you lose major marks if you don't have that direction because you don't even know what the direction is. So that's this one. That's 46. And number 47, I've copied it with the answer here, but this is the challenging elevator one. This is the hardest this gets, and it's not that hard. Again, elevator. You start off drawing the free body diagram for every elevator. Boom. Sound effects good for you. And it's accelerating up. Oh, that's easy then. Acceleration is up. Not really. And the object weighs 90 newton. It doesn't say its weight, 60 newton by the way, but it didn't say its weight. It says it weighs. So this normal force is 60 newtons. What is the mass? So that's what we're trying to figure out. So we write down Newton's second law, F net equals ma. The sum of the forces. Boy, did I kind of abbreviated that pretty quick. Eh? The sum of the net forces doesn't make sense. Sum of the forces is equal to F net equals ma. So we know it's upwards, so this one's winning. So normal minus the force of gravity is equal to ma. The problem is the force of gravity is mg. We don't have the mass. We don't have the mass. The mass is in two locations. So let's fill in the number 60 minus m times 9.8 equals m times 1.8. How do you solve it? There's two m's in both. This is algebra. It all of a sudden screams to you, this is why we did all that math. 60 is equal to 9.8 m plus 1.8 m. I just there, and this one I brought over to the other side to make it positive. So this is going to be 11.6 m. So that means m is going to equal 60 divided by 11.6. And according to Mr. Calculator, 60 divided by 11.6 is 5.172. One extra sig fig than the answer to show that I know what I'm doing. Here we go. This is a hard one. Why? Because it requires Math 9, algebra. and people are just not ready for it. Anyways, those are great questions. Thanks for paying attention. Here comes the jingle.